Hello. Hello. Hope I'm clear with my audio and as well as all the other things that are required for smooth presentation. Thank you. Hello, students. Hello, Ritesh Sri. Good evening. Yeah. So, hope you had a nice weekend. Yes, and we had one session last class, which was on the part one of basic concepts of chemistry. Yes, if you have any doubt regarding that session, you can just type down in the beginning itself. I'll clarify that and then we can go ahead. Okay, yes, fine. Today onwards, the sessions are going to be more interesting as well as more learning will be there because these sessions will carry weightage in your JE exams. So that is why I expect as of now only Ridhishri is there and whoever joins to be more attentive in the class. Okay. Yes. So today we will be learning about measurements, which we do usually for any experiment, for any data that we want. We have to conduct certain experiment and then we have to do certain measurements. And these measurements have to be precise as well as accurate. What does it mean to be precise as well as accurate? Yes. So precision means it is the closeness of various measurements for the same quantity. Yeah. For example, if the experiment says weighing of ball or football, weighing of ball, and let's say its exact value is 500 grams, and if you are getting in three trials value to be 491, 491.3 and 491.4, then all of this are very close to each other, isn't it? So then we call this value to be precise. It's closeness. You should be very much concerned about this term closeness. So when the values are very close to each other, then we call it as more precise. Okay. And when the value that you are obtaining, okay, agreement of a particular value to the true value, that means if exact value is say 500 gram, and if you are getting somewhere let's say 499.9, then you can call it is accurate. Okay. Or if it is let's say 500.1, which is very near to in grams, yes, which is very near to 500 grams, then you can call it is accurate. Clear? Yes. Similarly, we have another example. Yes. Before that, let us just go through this. Accuracy is expressed for each measurement. That means I can tell each trial is it accurate or not. And precision means based on all the three trials, if your data is coming to be equal to or near to exact or not. That's what precision means. Okay. For successful experiment, both the experiment should be both accurate as well as precise. Okay. It should be accuracy also should be very high and precision should be also very high. So next, let us take another example. Let's say true weight of a substance is 3 gram and I am conducting 2 trials with each student. Can Ridhishri just think over this and comment what is the result of student A, what is the result of student B, and what is the result of student C in terms of accuracy and precision? Is student A accurate and precise? Is student B accurate or precise? Is student C accurate or precise? Yadish, you can comment. Yes, maybe I'll give you 10 seconds. Just think over it and tell whether these two values are precise. Whether these two values are precise. Student B is accurate. Very good. Yes. B accuracy is high. What about precision? What about precision? What about precision? Yes. And whereas for student A, accuracy is low, and student C, precision is low. Okay, precision is low. Whereas I can tell if accuracy is high, it's sure that precision is high. Yes, very good. Precision of A is high. Okay, for student B, I can tell precision is high. So if accuracy is high, definitely precision should also be high. If accuracy is low, then precision can be either high or low. For example, here accuracy is low, but precision is high. Whereas in the other case, precision is low and accuracy is also low. Okay, so if accuracy is low, either precision can be low or precision can be high. It depends. Clear? So this is what is the whole conclusion. Precision means closeness. Accuracy means to the exact value whether it is matching or not. Okay, fine. So as we correctly found out, measurements are close for A and not accurate. Measurements are close and accurate. Measurements are not close and no accuracy. Okay. Yes. So in physical measurements, this is what our conclusion is. In physical measurements, accurate results are generally precise, but precise results need not be accurate. Okay. So if it is accurate, definitely it has to be precise. If it is precise, it does not mean that it has to be accurate. It can be precise, but still not accurate. Okay. Yes. Again, the same example that they are giving. See here, not accurate, not accurate. But in one case, precision is high. In another case, precision is low. Clear? Whereas when accuracy is high, precision will be definitely high. Fine. Yes. Going ahead. Scientific notation. This is something very important in chemistry. You should be knowing how to perform calculation with scientific notation. Till now, I think whenever questions used to come, 10 power 3 plus 10 power 6. Can you tell me the answer? Yes, Sagrishi? Usually our way of approach will be 1000 plus, you can tell me answer. Okay, 1000 plus 1000000. So it will be 1001000, isn't it? But now we have got something called as scientific notation. So what is this scientific notation? It is a general form which all over the world people follow. Very good, Ridhishri. Yes, it's correct. But now I am going to tell you another way, that is scientific notation, in which uh, yes, so all over the world people prefer writing it in a particular way, wherein this we write it as capital N. For example, if this is the number, then we write 0 to 10, any number between 0 to 10 as n, and whatever remains into 10 power whatever comes as 10 power n. For example, if it is 0.00000002 8, then what will I do? I'll move this in such a way that my decimal should come in a place where I'll get a number in between 0 to 10. Okay, so that's how I have to move my decimal. So how many times I have moved the decimal? 1, 2, 3, 4, 5, 6, 7, 8. So since I have moved 8 right, it will become into 10 power minus 8. Getting it this way? That if you are moving it to the right, that means basically what you are doing, you are dividing it with 8 times 0. Okay, that's why it will come 10 power minus 8. Whereas when bigger numbers are there, then I'll have to assume that here point is there, and that I'll have to move to the left. Okay, so when I'm moving to the left, I have to count how many times I'm moving till I reach to the number which is in between 0 to 10. Okay, yes, yes, you are understanding nicely, Rishmi. Yes, so when I'm moving it to the left, it will become plus 9, because I'm moving it with 9 decimal places. 1, 2, 3, 4, 5, 6, 7, 8, 9. So it will be 4.2 into 10 power 9. Yes, getting it? Yeah. So just try out this 7,800. Can you write this in scientific notation? Yes. I'll give you 10 seconds maybe. Okay. In the same way, in this scientific notation only, we can also do addition, multiplication, subtraction, and all of those. Yes. 7.8 into, it's 10 power 3. How it is 10 power 3? You will have to move 1, 2, and 3 decimal places. So it will be 10 power 3. Clear? Yes. So, yeah. How to perform various operations like addition, multiplication, subtraction, all of this I'm going to teach next. Okay. Yes. Before that, let us go a little ahead and try to understand. Now that we have got to know significant scientific notation, we'll try to understand something called as rounding off of a number. Before that, let me just explain to you why exactly scientific notation came about. Hmm? Before I start explaining, I'll just ask you, can you tell me atomic mass of hydrogen? Atomic mass of hydrogen. Okay. So, going with the explanation, the chemistry is alone such a subject which has vast number range of values. Okay, if you take Avogadro number, I think you might have learned about this in 10th. Yes, 6.022 into 10 power 23. Yes, and there are very least values which are charge of an electron, which is 1.6 into 10 power minus 19 coulomb. Okay, yes. So our chemistry covers vast range of values, and if you want to perform calculation, for example, instead of writing 6.022 into 10 power 23, if I would have written it in this manner, let's say into 1.6 into 10 power minus 19, which let's say instead of writing this, if I would have written it as 0.00000 up to 19 times 16, the multiplication of these two numbers will be very difficult, isn't it? So that's why we have scientific notation, in which how will we do multiplication? If say if you want Na Avogadro number into E, it will be 6.022 into 10 power 23 into 1.6 into 10 power minus 90. Okay. If you want to perform calculation for this, how will that be? Yes, these two I can multiply directly. Yeah, which is 6.022 into 1.6, approximately 10 it is, into these two I can multiply separately. Okay, now how to multiply 10 power 23 into 10 power minus 19? Can any one of you tell? Jagdish, welcome to our class. Yeah, just try doing it and tell. 10 power 23 into 10 power minus 90. If anyone can answer. Yes, add the powers. Very good. So this I already told, value is 10 into 10 power 23 minus 19. Very good, Ridhishu. So it will be 10 into 10 power 4, which is 10 power 5. Okay. So our calculation became very simple, isn't it? By converting it into scientific notation. That's why we use scientific notation. Okay. Yes. So next, let us look at rules for rounding of a number. Okay. This always was a controversy in my head. Okay. Whenever I used to get maths paper or science paper, I used to see 23 1/4 by 25 or 23 and a half by 25. Few teachers used to write it as 23, few teachers used to write it as 24. So whether I should consider 23 to be correct or 24 to be correct was a big question. Yes. So there is certain set of rules for rounding off of a number. Huh? If some number is given, if you want to round off, what are the rules? Okay. Step by step, we'll try to understand. Okay. Listen carefully. By the way, is there any doubt in whatever we have discussed till now? You can just comment, Vidishwi and Jagdish. Yeah. First rule. First rule says if the last digit to be rounded off is less than 5, the digit before that is retained as such. Okay. So the last digit, that is 2, if it is less than 5. So 2 is less than 5. So whatever is there before that will remain as it is. Okay. So it will be 1.75 only. Okay. Quite logical also. If the, I'll just remove this. If the last digit to be rounded off is more than 5, that means what? Last digit is more than 5. For example, 6 is more than 5. Then one digit which is prior to 6, we need to round it off to a higher value. One value higher. So 1.75 will become 1.76. This is also quite logical only, isn't it? Yes. Third rule, which says if the last digit to be rounded off is 5. Okay, this is where the controversy lies. If the last digit to be rounded off is 5, we increase the digit before that. Hmm? So if 5 is there, before digit is 5. So that we increase by 1 if that digit is odd. Okay. So we got answer for our controversy 23.5. If that is the value you want to round off, then 5 is the last number. If the preceding number is odd number, you need to increase it by 1. So it would have been 24. Yeah, my teacher cheated me by giving 23. Okay. Or retain as it is if it is even. So instead of 23.5, let's say if it was 24.5, then I would have been given only 24. Okay, because the preceding digit is even, correct? So when it is even, we don't add. Even, don't add. Odd, add 1. Clear? Yes, you can comment. Yeah, I think one more student has joined. Yes, going ahead. Significant figures. Yes, can anyone tell me English meaning of what significance mean? Significance, what does it mean? Yes. So, going ahead with our discussion, if weight of a substance is expressed as 7.52 gram, it indicates that it is reliable to the nearest hundredth of a gram. In other words, slightest variation may occur at the second place of decimal. Okay. Yes. So what does that mean? So whatever value is given, let's say 7.52 gram is given, that means this value is accurate up to this number 0.01 hundredth. Okay, that's what hundredth means. But the 7.52 gram can also be 7.521. We don't know. Somebody might have rounded it off to 7.52, isn't it? It could be 7.522. It could be 7.523. It could be 7.524, or it can be 7.525 also, isn't it? Because previous ones is even, so we don't increase. Even means no increase. Odd means increase by 1. Clear? So these are all the possibilities. So I can say it is significant only to this, isn't it? That means 3 places are significant. That means 3 places are of significance or of some value. Whereas the third, which is third decimal value, is insignificant. We need not to consider that. Clear? That's what significant figures mean. In each case, the significant figure will be different. Yeah. Okay. If we express measurement of length as 6.124 meter, it means it's reliable up to 1 by 1000 of a meter in a same way. That means only up to this value it is accurate. Okay, after this it may not be. So we consider only 4 numbers are significant. Clear? 1, 2, 3, 4. This is in general about significant figures, but in specific cases, how to find number of significant figures. From JE, I am telling you students, definitely one question from basic concepts of chemistry comes, sometimes it will be significant figures only. Okay, they will just ask find the number of significant figures. Such kind of questions can also be there. So if we just listen carefully and understand all the rules of significant figures, then directly put that and get the answer. That's all. Okay. Yes. So one more interpretation of significant figures is reliability of a data or measurement is expressed by number of significant figures. Okay. So how much reliable it is? Hmm? For example, 6.124 meter is reliable up to third decimal. You can rely on that value up to third decimal. Fourth decimal, no. Okay, that is one more way of expressing significant figures. Higher the significant, more is the reliability. Okay. Yes. So first rule. Are you all writing it down? You can write it down. This is like crisp notes, okay, which you can refer previous to exam and everything. Okay. First rule: all non-zero digits in a number are significant. So whichever number are not zero, we consider them to be significant. For example, 6.4234, all are non-zero. So 1, 2, 3, 4, 5. 5 significant figures are there. Okay, how many digits which are non-zero? All will be significant. Okay, yes. Your chat has gone to silent. Huh? You can ask me questions. If you are understanding, you can tell yes, sir. Okay, sir. Some I should get to know. Okay. Yes. Second rule: zeros in between two non-zero numbers are always significant. First one we understood. Whichever are non-zero, they have to be significant. Second one, whichever zeros are in between non-zero numbers, they are also significant. Okay. So for example, 7.0016. In this case, these two zeros are also significant because they are in between 7 and 1, which are non-zero. Okay. So totally there are 5 significant figures. Yeah. Okay. Third rule. Zeros on the left side will never be significant of any number. Yeah. That means in the beginning, if there are any zeros, they will never have significance. Okay. Including zeros used to indicate decimal are not significant. For example, 0.0016. In this case, this 0 not significant, this 0 not significant, this 0 not significant. So there are altogether only two significant figures. Yeah, before decimal and after decimal places. Yeah, after decimal places, it will have significance. Okay. See, fourth rule. Yeah, this was the answer for Ridhish's question. Um, Fourth rule says zeros on right side of a number are significant if they are a part of decimal number. Okay. To the right, if they are part of decimal number, then they are significant. If they are not a part of decimal number, then they are not significant. Provided in one case they will be significant. That I'll explain. Okay. So till now what we learned, to the left, if there are zeros, they are insignificant, no matter decimal is there not there, need not to worry. If they are to the right, zeros are to the right side, and if there is a decimal, then all the zeros will have significance. For example, here 1 2 3 4 5, so there will be 5 significant figures. Okay. Fifth rule: zeros on the right side on a whole number will not be significant. Okay. Yes. So if there is no decimal, these are not significant. Zeros are not significant if there is no decimal to the right. Okay. Only two significant figures will be there. Okay. And sixth point, trailing zeros will be significant. That means what? Even if there is no decimal, it can be significant if the measurement is given with the unit. Okay. The measurement is given with unit, then it will be of significance. For example, 750 has two significant figures, whereas 750 kg, that means unit came na, so it will be three significant figures. Okay. Yes. So, is this all clear to you? Significant figures. Yeah. Last point, seventh one. In an exponential number expressed in scientific notation, in an exponential number or number expressed in scientific notation, significant figures are given only by the numeric. Okay. That means what? Only this one is given significance. Okay, so 2.8, that means only two significant figures. This we have to ignore. 4.2 means two significant figures. We have to ignore this. Clear? Okay. Yeah. So here is the exercise for all of you to check how much you have understood. Quickly, out of this 5, I want you all to answer one by one. Okay? Yes. Let's see. 10 seconds. Quick. Okay? Yes. How many significant figures are there in following digits? First question, 0.0426. How much it is? Zeros to the left will have significance or it will not have significance? Yes? I'm not getting any answer. Quick. Yes, 0 to the left will not have any significance. So these two gone. So the answer is it has 3. Very good, Sarai. It's 3. Yes. Second one, 526 ml. Yeah, one has 3 significant figures. Yes, correct. Second one, 526 ml. How many significant figures 526 ml has? Yes, 3. Very good. Third one, 4.5 into 10 power 3 kg has how many significant figures? 4.5 into 10 power 3 has 3 significant figures. Very good. Fourth one, 0.00269 has how many significant figures? Yes, it has 3 significant figures. Okay. Yes. And last question, 2.725 into 10 power 4 has how many significant figures? Yes. How many significant figures are there in the fifth question? Quick. Yes, all of you are answering very nicely. Yes, very good. Very good. Very good. Sarayu and Ridhishri. I think Jagdish can also reply. 2.725 has 4 significant figures. Very good. Okay. Yes. So going ahead, how many significant figures are there in following digits? Yes, try this one. 2.365 into 10 power 3. 2.365 into 10 power 3. How many significant figures are there in this? Yes. Quick. 2.365 into 10 power 3. How many significant figures are there? Yes. 4. Very good. It's 4. 6.00 into 10 power 4. How many significant figures? How many significant figures? Yes. 7.240. Second one, 6.00 into 10 power 4. It has 3 significant figures. Why? Because in case of exponents, these also becomes significant. Clear? Yes. So in the same way, this will also be of significance. This is one more thing which you need to keep track of. Okay. In the same way, fourth one, how many significant figures? It will be 2 significant figures. Yes. Very good. Very good. I think Sarayu and Ridishi both are understanding very nicely. Okay. This is about significant figures. Yeah. This is what questions may come. Okay, and there is one step ahead in significant figures in which we perform addition or subtraction and multiplication or division using significant figures. Okay, so answer has to be reported in a particular manner, and what is that manner we will learn. Fine. Yes. So calculation involving addition and subtraction. First one, that is addition or subtraction. The final result should be reported to the same number of decimal places, as that of the term with the least number of decimal places. Okay. So for example, if I have these three numbers, yeah, 2.512, 2.2, 5.23. Can you tell me what will be the sum of this? Yes, if you perform, it will come out to be 9.942. Okay, 9.942. But while telling the result, you should never tell 9.942, because you do not know what was there after this, isn't it? So this was precise, or this had a reliability of only 1 after right of decimal. So that's why you have to report with only one decimal to the right. Okay, whichever is minimum, you have to report that at the end. Clear? For example, in this case 2.512, here there are 3 digits to the right of decimal point, here there is 1 digit to the right of decimal point, and here there are 2 digits to the right of decimal point. So when you are telling answer, you should choose one among these three, that is this one. Okay, which is 9.942. I'll ignore. You should not just ignore, you should round it off. Okay, for example, if you would have got 9.963, then you will have to round it off to 10.0, because 9.963, 6 is greater than 5, so preceding number should be increased by 1. Clear? This is how we apply our significant figures in case of addition or subtraction. Okay, yes, yeah, this is question for all of you. Can you just try this and tell me the answer? 34.72 plus 8.1. 34.72 plus 8.1. How much will you get? Yes, quick. Yes, normal addition only, and then you will have to round it off to a minimum decimal. Minimum decimal. So for example, over here 34.72 plus 8.1. So when you do addition, it will be 2718.4 plus 8, 2, 12, 142. How much it will be? Since it is 42.82, I should round it off to 1 decimal. So I'll remove this because it is less than 5, and I'll write it as 42.8. No, Ridhishri, it's not 42.82. It will be 42.8. Yeah, when you add, it will be 42.82, but final one will be 42.8. Clear? Yes. So 42.82, but when we are reporting, we have to report it as 42.8. Yes, one more thing you all should note down over here. Even when you are doing normal calculation, take care of this significant figure. Okay. Yes. For example, when you are normally also doing calculation, 1.8 plus 3.26, when you are adding this, take care of significant figures. When you are reporting, your answer should be 5.1 and not another decimal value. Okay, it should be just 5.1, because then only your values will be more accurate. This is just the side point. You can remember this. Maths or physics or chemistry, if you are performing any calculation, keep it to significant figures. Maintain your significant figures to get right answer at the end. Otherwise, decimal wise, it may go wrong. Okay. Yes, yes, yes. Very good. Yeah. Do this. Let's try. For 59.273 minus 24.92. Tell me the answer quickly. Let's see. Ridhishri or Sarayu or Jagdish. I don't know Jagdish is there or not. Did he leave? Yes. First perform normal subtraction and then report it in how many decimal? Two. Two decimals. Yes. So if I start doing it, it will be 59.273 minus 24.92. So when we perform this subtraction, it will be 3, 7 and 2 will be 5. For this, I have to bring one from other side and it will be 3. 8, 4 and 5 minus 2, 3. Yes, very good, Ritishri. The answer is 34.35. Okay, yes, that's all. Isn't it easy? Yes, make sure to use this. Okay, so it will be 34.35 up to 2 decimal places. Why? Because 2 is the minimum of 2. Next, how to perform multiplication and division when we are considering significant figures. Yeah. So in that case, what we have to do, results should be reported in the same number of significant figures as least precise term, or the term with least number of significant figures. Okay. So for example, if this is there 15.724 divided by 0.41, all of you can quickly type that which one is least and what is the significant figure among these two. The least and what is its value. Okay. Yes. So when I perform this division, I'll get this value. But while reporting, what should I report? Here it says we have to report in same number of significant figures as that of least, so among these two least is obviously this, and the value the number of significant figures is 2. Okay, the number of significant figure is 2. So when you are reporting, answer should be 38. Okay, got it? Yes, so it will be 38 in two significant figures. Fine. Next, try to solve this question. Give the answer by using significant figures principle. 9.24 into 3.6. 9.24 into 3.6. Just do this multiplication and tell in terms of significant figures. Maybe you may need little more time. Just try doing it. But I want active reply from all of you. Yeah, it's very good that Redishmi and Sarai, you both are replying very nicely. Yes, getting it. 9.24 and 3.6. Do the multiplication. Whatever answer you get, you make it to how many significant figures? Two significant figures, because this has two significant figures. Okay. Yes. So 9.24 into 3.6 is 33.264. So while writing the answer, we'll write it as 33. Yes, 33.26. Correct. But since here there are two significant figures, answer should also have two significant figures. So it is 33. This is anyway 33.264, but I am going to remove this 3 because answer should be reported in two significant figures. Did you all get it? You can just type if you are getting it. Okay. Yes. So this is a basic idea, yeah, and in that it's covered fully the significant figures, accuracy, and precision. Okay. Yes. Next, chemistry is governed by various laws. And in the beginning, when Dalton gave his atomic model, we had laws of chemistry in accordance with it. Okay, as soon as they got to know that matter is composed of atoms or molecules, they formulated this laws of chemistry, and they made sure that every atom and every molecule obeys this law. Okay, so last class I was telling you about chemical classification of matter. Remember, we did pure substances and mixtures. So pure substances are those which contains either only elements or they contain only compounds. Elements means only one type of atom. Compounds means more than one type of atom. Okay, whereas mixture contains two or more different molecules in it, either in a homogeneous way. Homogeneous means evenly it is distributed throughout the matter. For example, salt plus water. Okay. So salt plus water, they are evenly mixed in a homogeneous solution. Whereas in case of heterogeneous, it is not evenly mixed. Example could be rice and stones. Rice and stones in it. So if you take a rice bag, and if it has impurities, stones like impurities, you will see that they will be more at the bottom. So they are distributed heterogeneously, isn't it? So this is the example for heterogeneous mixture. Yeah. So this I already discussed last class. Okay. Now this yeah, homogeneous mixtures are those which composition for 1 minute. I'll just remove this, whose composition for each part remains constant. For example, salt in water or gas mixtures. Heterogeneous mixtures are those whose composition may vary for each and every part. For example, rice above may be having no stone, whereas below it may be filled with stones. So that means it is example for heterogeneous mixture. Okay. And all of this obey certain laws. Okay. And they came across this observation during analysis of chemical reaction, and they have summarized it as basic laws. First one is law of conservation of mass. That means since you all have already gone through inorganic chemistry, now I'll directly use the term reactant and product. Okay, in a reaction, mass of reactant and mass of product should be same. That's what law of conservation of mass says. More about this I'll discuss it in a coming class, next class. Okay. Second one, law of constant proportion or fixed proportion. So that means what? In every molecule, the atoms mix together to form molecule in a fixed proportion. So that's what law of constant proportion or fixed proportion means. Then there is law of multiple proportion, which I'll explain in the next class. Law of reciprocal proportion, again we'll look at it in next class. Then Avogadro's law, Gay-Lussac's law of combining volumes, Dalton's atomic theory. Yeah, Dalton's atomic theory is one theory which you have already learnt in atomic structure. Dalton was the first one to come up with atomic model. He said that it is atom is something which consists of smallest indivisible particles. So that's what we call it as atom. But then we saw that in atom there are proton, there are neutron, there are electron. Yes, and now there is so many things related to atom, isn't it? Orbitals are there, and then we call electron to be behaving as wave. So it goes into a vast area. Okay, beginning with our Dalton's atomic theory. Okay, yeah. So hope you all understood this. In upcoming class, we will be learning about various laws of chemical combination, as well as now, since little time is there, I'm going to give you 5 questions. Try doing it, okay, in significant figures multiplication. Hmm? Just take them. First one, 9.3 into 0.32. Okay. Second one, 3.6 into 4.25. Third one, 7.83 into 10 power 3 into 1.20. Fourth one, 7.83 into 10 power 3 into 1.20 into 10 power, let's say 6. Yes. Yeah. Uh, we have 2 minutes. Just try doing it, because every question in JE carries 2 minutes, right? So try doing it. Tell me the answer. For first question, what is the answer? You have to use significant figures after multiplication. Clear? Yes. Last one, maybe I'll give you division as well. 2.5 into 10 power. Yudhishri, Sarayu, Jagdish, all can reply. Yes, what is the answer for first question? Yes, not getting? Okay, first one, 2.98. Very good. Uh, Decimal alone, can you check? Significant figures alone, can you check? Yudhishri once. You're telling 2.98. Just check significant figures and tell me. It's correct. It's correct. But significant figures alone, you can check. Yeah. Second one, 15.3. Even this, can you just check significant figures? Others can also answer. Yes. Yeah. Videshwi said this is 2.98 and this is okay. No, that's what not I was saying. I was saying this has to be rounded off to minimum significant figures. Which one has? First or second? First or second? First one, right? So this has two significant figures. So answer should mean two significant figures, which is 3 3.0. Okay, should be 3.0. Whereas for second one, minimum of these two, 3.6 and 4.25, which one will be having least significant figure? Yes, can you recheck second question, and others can also comment the answer for second one. Answer for second one. First one, correct answer is 3.0. Okay, this has significant figure problem. Otherwise, first one is also correct, but significant figure wise it is wrong. Yes. Second question. Second question. Yes, others can also participate. Others can also comment. Yes, all of you can speed up. Okay, because JE is all about how fast you do. As well as NEET. Even in NEET, such questions can come up because these are easy ones and you can do it quickly also. So you can score. Yes. Second one, answer is 50. It's 50 because here there are two significant figures. Here there are three significant figures. We have to select among these two. So answer will be 50. So 15 is correct. Third one. Third one, what is the answer? Yes, third one, what is the answer? Since calculation is difficult, all of you are neglecting to do a. Yes. So for second one, here 7.83 has three significant figures and 1.20 so has three significant figures. Yes. So in that case, our answer would be in three significant figures. How much it will be? 3 means how much? Yes. It's 9.396. So answer will be 9.40. Okay. Yes. Whereas over here, yes, quick. One more thing. 9.40 plus this also should be included. Yeah, that's why I think I am not getting reply. This, how to include this? This we can include as it is, because it is not the part of significant figure. Only the n, the capital N in 10 power n into 10 power n in this scientific notation, only for capital N we need to worry about significant figures. Okay, whereas for this exponent you can just write it as it is. Yes, now that you know this, can you tell me this? With this we'll end. Fourth question. Fourth question. Yes, try answering it. Yes, no answer. Yeah, anyone? Yudhishri, Rayu, Jagdish. Okay, maybe 10 seconds. 10 seconds. Just try answering this question. If not, you lost. Okay, yes. So for this question, how to do is that basically again the same thing. Whatever is capital N, that I have to consider 7.83, 1.2 and 2.5. For that I will have to perform the calculation. So when I do that, how to do it is the question, isn't it? So I'll tell you one easier way. We already know 7.83 into 1.2 is 9.396. If not, you can just calculate and recheck. It is 9.396 divided by 2.5. How much is, how to do this? Whenever this kind of number is there, try to bring denominator to 10 somehow. So to bring it to 10, what I'll do, I'll multiply this with 4, I'll multiply this with 4. So then in the denominator, 2.5 into 4 is 10. Got it? So this how we can simplify. And the numerator will become 4 into 9.396. Just perform this multiplication. You will get 4, 2, 36, 8, 3, 5, 1 and 37. So you will get 37.584. Answer should be told in minimum significant figures. So here it is 3, here it is 3, here it is 2. So answer will be in two significant figures. So what will be the answer? It will be 38. Okay, so 38 is the answer for fourth question, because this is greater than 5 is there, but next number is greater than 5. So that's why I'm rounding it up to 38. Yes, any doubt? Then just type if you are having any doubt. Otherwise, we will have class the coming next class. In the next class, we will learn about law of chemical combination. Yes. Can you just tell what does that mean? Two, Ridishi? What is that two mean? Yes. Yeah. What does that two mean? Okay. Maybe answer for some previous question. No problem. Yeah. Thank you very much. Yes. Thank you very much. Bye.